Let's take a look at quiz 5. Question 1. Tell you this reaction delta H standard reaction enthalpy is 20 kilojoule per mole. As you predict the change in equilibrium constant Kc that would occur if the temperature of the reaction system was raised. So if temperature raised, this will cause Kc increase becomes larger or decrease becomes smaller. So clearly this tell you this delta H 20 kilojoule per mole. This means this is absorbed heat. This is endothermic reaction, right? If negative, the release heat, exothermic reaction. Because this is positive. So positive, this tell you absorb heat. So this reaction absorb heat. If you raise temperature, then clearly the equilibrium shift toward the right? So when temperature raise, equilibrium shift toward the right, then Kc will be greater or larger. So your choice must be A. Your choice must be A. Kc should become larger. If this is an exothermic reaction, then delta H is negative. Then raise temperature, then we'll shift it back. Then your Kc will be smaller. Then question 2. For the reaction of 2 HCl breakdown becomes Cl2 and H2. Equilibrium constant Kc is 4 times 10 to the negative 30 the power at 25 degrees Celsius. Ask you what is the Kc for the reverse reaction. So Cl2 react with H2 produce 2Cl. So this Kc equal to what? So clearly this is a reverse reaction of the original reaction. Then this Kc will be reciprocal of the forward reaction. And do you remember we talked about this? Because this Kc is HCl in top, HCl raised to second power in top, right? And this Kc prime equals to HCl raised to second power divided by H2 and Cl2, right? While this Kc, the Kc for the forward reaction is H2Cl2 in numerator, while HCl in denominator, right? So their relationship is reciprocal relationship. So Kc prime equal to reciprocal of Kc, then 4 times 10 to the negative 30. Use your calculator to find the value of 1 divided by 4. It's clear as 0.25, right? And 10 to the negative 30 in denominator, then 10 to the positive 30. Then this is less than 1, so we need to move 1 decimal place. So it becomes 2.5. Since we move 1 decimal place, so we need to decrease 1 here. So 10 to the 29. So your choice will be C, 2.5 times 10 to the 29th power. So your choice is C. Okay, this is pretty simple, right? These two are multiple choice. Start question 3. You need to work. Okay, not called multiple choice. Question 3. Ask you write equilibrium constant Kc and Kp if applicable for the following reaction. I remember at the beginning of the quiz that I remind everybody Kp only applied to gas involved the reaction. If no gas involved, then no Kp. Even though I remind everybody, but we still have some students didn't get it. Like A, this reaction is a gas reaction, and a couple of students write no Kp. This all gas include reactant and product. All gas, how can it be no Kp? This definitely have Kp, right? Reactant gas, products also gas. Of course, we have Kp. Then this Kp is product in top. Product you have CO is 2, so PCO raised 2. Okay. In order for you guys to be more clear, I label with different color. Why this is 2? Balanced equation tell you 2CO there. So raise 2 second power. And another product is O2. This no number means 1. Then this no number means 1. Reactant in denominator, so CO2. Is this correct? No, because here in 2, you need a label 2 here, right? This is Kp. That means use pressure to express equilibrium constant. Then what is Kc? Then this is so easy. You just use concentration instead of pressure. Formula is very similar. So reactant CO raised to second power because you have 2 in the denominator in the balanced equation. So CO concentration raised to second power. And O2 concentration, no number, means 1, right? Still 1. Then CO2 also second power because in the balanced equation you have coefficient 2 there. Right. Reaction B. CH3COOH AQ. What does the AQ means? This means aqueous solution. So this substance dissolved in water make a solution. CH3CO minus also AQ plus hydrogen ion also AQ. So AQ. Reactant products or liquid solution in water. No gas. So no Kp. Only Kc. So Kc will be product in numerator. Both no number means 1. Right? Reactant in denominator. No Kp because no gas involved in the reaction. And there Then question 4. For the reaction N2 react with O2, both are gas, produce 2NO gas if the equilibrium partial pressure of N2, O2, and NO are 0.5, 0.73, and 0.12 atm respectively at 500 degrees Celsius. Also, you calculate the Kp. So tell you partial pressure of N2 is 0.5 atm. Partial pressure of N2, oh sorry, so start N2, O2, and NO. So N2 is 0.5. Yeah, N2 is 0.5. Then O2. O2 is 0.73. And NO is 0.12 atm. After you calculate the Kp, this easy. Or this is cannot be easier than this. As long as you understand how to write Kp based on this balanced equation. Whenever give you a balanced equation, you need to immediately realize how to write Kp or Kc if no gas involved, right? So Kp product, Kp Kc always product in the numerator. So product is NO. So NO. NO in numerator, so 2, that means you need to raise to 2. Raise to 2's power. Then reactant, nitrogen, and oxygen. Both no number base 1, right? So now we just plug into pressure. NO 0.12 raised to second power. N2 0.5. O2 0.76. Then use calculator, you can easily get the Kp will be 0.0395. For this problem solving should work, each step worth some. If you give this correct formula, I give some point. If you plug into correct number, I give you another part credit. Find the answer. Another. Okay. There's 3 points. Find the answer maybe only find the answer only worth 0.5. Should work is the most important. Are you okay then? Okay, this is a so far this is a very easy problem solving. I wish everybody can solve it if similar type of problem shown in the test. Otherwise, you cannot pass any test in the future. It cannot be easier as this. Question 5, the reaction is 2CO. React with 1O2. produce 2 CO2 gas. If Kc 2.35 times 10 to the positive 21 power at 1200 degrees Celsius. Ask you what is Kp. So clearly here test you Kp Kc relationship. Or tell you gas constant R is 0.0821 liter ATM per mole per K. So here test use the Kp Kc difference. So Kp equals Kc times RT times delta Ng. What means delta Ng? You need figure out this. Delta Ng is more than gas difference between product and reactant. Product gas 2 more. Right? This is product. Reactant 2 more CO plus 1 more. No number means 1. 1 more O2. So 2 plus 1. So this is -1. Right. Temperature 1200 degrees. Temperature must be in Kelvin because this is R is per K. We cannot use Celsius directly. Have in mind, in chemistry, most case we must use Kelvin if temperature required in the formula. Most cases we must use Kelvin. Only if the temperature difference delta T, you can either use Kelvin or use Celsius, because temperature difference in Kelvin in Celsius is the same. Right? So in Kelvin, then plus 273. More accurately is 273.15. Use 273 is fine. Okay. But if we use 1200 directly, this is wrong. Okay. So 1473.15 K. Now we can plug into this formula. Equal to Kc is 2.35 times 10 to the 21 times R gas constant times T temperature in Kelvin raised to the power of -1. Then your answer will be 1.94 times 10 to the 19th hour. So again, this is your work. So there's 4 points. Each step worth some points. So this also worth some points. This also worth some points. This last step only worth 0.5. Okay? So show work is more important. Are you okay with this? Okay. You okay? Then last question 6. Equilibrium constant Kc is 2.5 times 10 to the 6 of the power for this reaction. H2 reactant ways Br2 produce 2 HBr. Kc is 2.5 times 10 to the 6 of the power for this reaction. This is a gas reaction. The reaction started with 3 moles of HBr in 15 liter. 3 moles in 15 liters. Since here tell you this K is Kc is concentration, so we must convert this moles liter into concentration, right? So starting with that's the initial 3 moles in 15 liter. So this is 0.5 molar concentration, right? Oh, no, sorry, 0.2 molar. 3 divided by 15, 0.2 molar. So starting with HBr, nothing else. Right? This means these two starting is 0. Nothing there. So clearly, this reaction will be from HBr backwards, reverse reaction. Decompose some, become H2 and Br2. Then how much this will be decomposed, we don't know. We need to figure out, right? Because here also you calculate the concentration of H2, Br2, and HBr equilibrium. So we need to figure out. So let's design this reaction as X. So produce X hydrogen and X bromine, then you need decompose 2X of HBr. Let me write here. So first is why this HBr is negative and H2Br2 both positive. You need to be careful because initially only HBr, no H2, no Br2. So this reaction must be reverse reaction. Initially, no of these two there. You cannot do from left to right. So only HBr started with HBr. They must be back. So that's why HBr serve as a red end, then this is negative, and then H2 and Br2 serve as product, then this is positive. Then when reach equilibrium, so clearly this hydrogen becomes X and Br2 also X, and HBr will be 0.2 minus 2X. Now we can list the Kc because here is Kc value. Clearly, you need to use this condition to solve for X. Right? So Kc will be HBr raised to second power H2 and Br2 in denominator, right? Okay, when you write a Kc or Kp, still this is the product. Even though the actual reaction is from right to left, because initially no this there, you cannot from left to right. But when you write a Kc for this reaction, still this formula. Okay, so now 0.2 minus 2x raised to second power x times x. This equal to 2.5 times 10 to the 6th power. It's a quadratic equation. You can use formula. But luckily, this is second power. X times x, also second. Right, so we can square root it. So square root this 0.2 minus 2x. Or this is x squared. Becomes 0.2 minus 2x over x equal to square root of this, right? Then 0.2 minus 2x over x equal to 1.58, 1 times 10 to the third power. Then solve this equation. So both sides multiply by x. Then move 2x to this side. this time x is 1581. So let's see. The rest is a pure mass. I'm not supposed to show you this part here. It's pure mass. Okay. So 1581x. Then move this to this side. 1583x. Then x equal to 402 divided by 1583. The 1.26 times 10 to the negative 4. You don't have to show me this. You only find the answer for x. It's fine. This is pure math. So show formula, give answer. It's fine. So as long as we get x, now we can here hydrogen concentration is x. Right? And bromine concentration also x. HBr concentration is 0.2 minus 2x. Okay, again, it is there was some point. And if you review your quiz 5 now, compare with those I talked and give assured homework, right? So if you listen carefully during the class, should be able to make it. Okay. Listen carefully during the class, save you lots of time.